This next series of videos is going to look at inequalities, their graphs, and then eventually solving them. And so when we talk about a solution of an inequality, we talk about any number that makes the inequality statement true. So take a few seconds to write that down. And then I'll show you what I mean. Here we have an example of x is less than 3. Well, if I asked you to write all the numbers that would make that true, you'd be writing for the rest of your life. You'd have to write 2, and 1, and 0, and 1.4, and -3, and -6, and all those numbers that are less than 3. And so, because there's an infinite number of numbers truly, we choose to graph them to show where all the solutions lie. So if I just put a 3 on my grid, just to show, where it is relatively to 0, and I wanted to show all the solutions where x is less than 3, what we do is we put an open circle around 3. Maybe you remember that. The open circle is kind of like a paper punch. That's how I think of it. It means that the 3 is not part of our solution set. But all the numbers that are will lie to the left of the 3. And so we just put an arrow in that direction that indicates all the solutions lie under this arrow, including the whole numbers, the integers, and those decimals that are there as well. So on this page, we're going to just review what all these symbols mean by matching. So either match this list here or write what you think the actual names are next to it. So pause the video and I'll type it out while you're working. And here is what you should have written. So look through your list, and if you need to make any corrections, go ahead and do that. And then I want to talk about these circles, open and closed, that are next to the symbols. I talked about it a little bit on the previous slide. Again, if there's a number that is part of the solution set, we would close that circle or fill it in. And those filled in circles will happen whenever you have an equal to symbol along with your inequality. That's what that little line means. It's like an equal sign that's created there. The open circles means our boundary number, or our number is not part of the solution set. So think of that again as the paper punch, that is not included. And this not equal to, it doesn't show up all the time, but just enough to confuse kids. So if you ever see an equal sign with that hash through it, that means not equal to. On this slide, we're going to actually write some inequalities depending upon the situation that's written. And your job usually is to come up with a variable that will work. You can use x, that's fine, or if there's another letter that you'd rather use, go for it, if it happens to describe the situation. So our first example here says a speed that violates the law when the speed limit is 55. Well, you might want to use an s for that. So I always start down using my variable. I write that first. And I know that 55 is an important number too. So which numbers would mean you get a speeding ticket? If the speed limit is 55, a speed that violates the law would be anything over 55. And so your speed would have to be greater than 55 in order for you to get that ticket. I think you can actually go 55. You always should do that mental check of whether or not you need an equal sign there, and I don't think you do. You would not get a speeding ticket if you were going 55, but if you were going over, you would. Second example is a job that pays at least $500 a month. So again, start with writing a variable. So let's use an M for money, or P for pay, or use an X, whatever works for you. But it's a job that pays at least $500 a month. So 500 is also an important number. And then you need to decide which inequality symbol goes in between those two. So if the job pays at least $500 a month, that means you're going to make more than $500 a month. And so we would hit the greater than symbol. And I think in this case we also need an equal to symbol because it's paying you $500 or more each month. Number 3 says a bus can seat at most 48 students. So again, pick a variable. I'll just do an X. Okay. So the bus can seat at most 48 students. So 48 is an important number. it can fit 48 students, and then sometimes I like to decide what else, like pick another number. So it can fit 47 students, but it cannot pick 49 students or fit 49 students. So you're going to need a less than symbol there because 47 is less than 48 and so on. But you also want that equal to symbol because 48 students can fit on that bus. Alright, I would like you to try number 4 and 5. So pause the video and write your inequalities and come back when you're done. And these examples are always fun to think about. It says we will have a snow day if there is more than 10 inches of snow. And in that case, I do not believe we'd have an equal sign because it needs to be more than 10 inches. It's not 10 inches or more. Number 5 says we will not have school if the temperature is less than 25 degrees below zero. And so we'll put a T, and I'll probably put a -25 because that's what we're really talking about there. So we will not have school if the temperature is less than that. No equal sign in this case either. And again, the negative temperatures that would fit in there would be -26, -27. You can always do that to make sure that your statement is really true. Okay, not only will you need to know how to write those, you're also going to need to know how to graph some of them. And so we're going to graph the following. If I have x is less than 5 and I just provide a number line, then you just put down that boundary number. You don't have to write every number. People will understand what you mean. So I'm just going to put a 5 there, and my solutions, or any number that can fit or be substituted in for x, are going to be to the left of 5. But now because I have a less than symbol with no equal sign, it's going to be an open circle, and my solutions, or all the numbers that make this true, are, like I said, going to be to the left. And so we shade that in with either a different color or a highlighter. The second one says -9 is greater than or equal to x, and this can mess kids up because the x and the -9 are reversed. And so you maybe can just do it. I always like to start where the variable's written and read it in that direction. So in this case I'm reading backwards, and this to me says that x is less than or equal to -9. That helps me graph it better. Worst case scenario, go ahead and switch your variable back over to the left side so you can read it properly, but make sure that your inequality symbol is still eating the same number, like the alligator. Okay, so we read this no matter which way you write it. X is less than or equal to 9. So you put that or -9. You put that boundary number down, and because it's an equal to sign with the inequality, we're going to fill in a closed circle. And your x values are less than -9, and those will be found over here, again to the left of -9. So -10 would make this true, -11 would make this true, and so on. We have x is less than 0. Why don't you, less than or equal to 0, you go ahead and do that one and the next one, and then save this last one, and we'll do that together. So hurry up and well, you don't have to rush, but do those two and unpause the video when you're done. And here's how those two should look. Now, I know sometimes kids start memorizing little tricks to know which way their arrows go, and I'm just going to caution you against that. Logic is going to be the thing that will survive beyond this class, so if you just read it and figure it out by substituting numbers in to make it true, that is the best way to learn these and retain that information moving on in your math courses. Let's hope you listen to me. Alright, let's look at this last one. It just says that x is not equal to -3, and so in that case, and it's kind of weird to graph these, but we'll do it, you're going to have a -3 here, and if you're not equal to it, then you might be equal, you're going to be equal to everything else. So you're going to like paper punch that out. -3 is not a solution, but everything else could be, and that is how we do this one, even though it's very odd looking, but just in case you run into that. So here's a question you will actually be asked a lot, and it seems a lot more complicated than what's really being asked of you here. They're giving you an inequality here, this 3 plus 2x is less than 8, and they're asking you which one of these is a solution of this inequality. And all you need to do is plug in the numbers or substitute them in as they're given to you, and if your statement turns out to be true, then you say that it is a solution. So let's give it a go and see if negative 2 is the solution. So I'll rewrite the inequality, substituting in a negative 2, and just run through the math with you. So I would do 2 times a negative 2, which is a negative 4, and negative 4 plus 3 is a negative 1. So the question is negative 1 less than 8? Well, yes, it is. And so this is a solution. Or negative 2 is a solution, I should say. Okay, so either way you want to do it. Say it's a solution, put a check mark, we're good. All right, 3, substituting that in. 3 plus 2 times 3 is less than 8. Is that a true statement? So 2 times 3 is 6, plus 3 is 9. 9 is not less than 8. So 3 is not a solution. Alright, and it seems pretty straightforward. It's just sometimes you wonder what the directions are asking you. So we'll put in these last two, and then this will end up being 0 plus 3, and then is 3 less than 8? Yes, a solution. 0 is a solution. And when I put a 2 in, you're going to get 3 plus 2 times 2. Is that less than 8? And that is true because 7 is less than 8. So again, you have another solution. So notice that with an inequality symbol, you can have more than one answer. With an equal sign, you can't always have this many answers, but I think you already know that. Alright, you guys try these, test these 4 and find out if they're a solution. Remember your order of operations and to show your work so we can find mistakes if you've made any. Pause the video. And here your answer should have been no, yes, no, no. And just to point out a couple things, make sure your 2 negatives became a positive. Don't worry too much about that, but I just used my fraction rules here and I multiplied by the reciprocal because I didn't have my calculator out. But I assume you probably used your calculator and got the same result. And please remember that 0 divided by any number is just 0, and so 0 is clearly not greater than 5. Alright. The final thing you may be asked with inequalities is for you to write an inequality for a particular graph that's given, and so you just need to use all those skills that you've learned throughout this video. And I use little tricks again. I always start with a variable, and I write down what I call the boundary number because I know that's involved, and then I decide what's happening with the red arrow. So I see that it's filled in, and so I know there's an equal to sign involved, and then I need to decide what my solutions are compared to 8. Well, since I'm shaded over to the right, I know all my solutions are going to be greater than 8, and again we said an equal sign will be involved because it's... Alright, next I'm going to use my variable again of an x, and I know negative 4 is important, and then I need to see that my shading is over all the numbers that are less than a negative 4. For example, negative 5, negative 6. So my x values, or my solutions, are less than a negative 4. I would not put an equal sign here because that is not solid. And if you're ever confused, just pick some numbers that would be found here on a number line and substitute them in and make sure you have a true statement. You do the last two. Pause the video. Come back.